25 we'll do next. And blue, I like the blue's pretty fun. So this is the problem right here. Y equals 3x and 2/3 minus 2x. And the interval is from -1 to 1. So we go back and go to y equals. And then we're going to type in that equation. If I run too fast, just pause it and then come back to it when you're ready. Because I really want you to get the feel of how to put these graphs in there. Because we're going to be doing this a lot in this class. And you hit the zoom 6 to get your graph without any particular changes from the standard. And now we do have to change it from -1 to +1. So you go to your window and change your x to -1 and your x maximum to +1. And you don't really have to change anything else, but the graph now is what you're ready to hit in. And you notice that it's going to look kind of like what I've got there. Now, here's the greatest problem with these calculators, which I dearly love, but you have to know their weaknesses. It's like a marriage. You get married to somebody, they're not perfect, so you just get used to their weaknesses. I'm married to my calculators because they do such wonderful things for me. And one of the things that they don't do well is deal with very small variations in curves. Because we're dealing with pixels of distinct length and width. So if there's a minor change, it has to be dramatic enough to change to another pixel, which is, so, but this is kind of what is going on there. You can kind of see how it's kind of curving down there, like this, then it hits this and goes off at a weird angle, different from what you had to start with. So, go ahead and put in your value here. You need to find your critical point here, or critical number first. So I'm going to move the -2 over here, so it's 2x to the -1/3 power equals 2, divide both sides by 2. We hit x to the -1/3 power equals 1. And then you get rid of the -1/3, I'll take this from the -3 power. And this gives you x equals 1. So x equals 1 over there. Okay? And then we have to find the y. So we're going to come down here for the y. I hate you so much. I hate this board. And now it's not going to be good. Well, that's fun. Anyway, so y equals 3 times 1 to the 2/3 power minus 2 times 1. Type that in the calculator. Be careful with this. Put a caret and put parentheses around the 2 divided by 3 and make it 2/3. And you do get 1. And that's why I have over here your critical point is 1, 1. And it is also your right end. Okay? Your left end is over here. That's where x is -1. Let's stop there. So y equals 3 times -1 to the 2/3 power minus 2 times -1. And when you plug that all in, you get a value of 5. So this right here is 5. So -1, 5. That is your left end, and that is your maximum. Now, this point right here is your minimum right here, and it looks like 0, 0. If you want to prove that it is 0, 0, then you go ahead and plug in 0 for x, and so we have y equals 3 times 0. I'm sorry, this equation here, 3 times 0 to the 2/3 power minus 2 times 0, and that is indeed 0. So this is 0, 0, and that is your minimum. We've identified all the parts for that particular graph. The last one I want to do is the trigonometry one. And this is a rather interesting one in two aspects. First of all, when you do the graph for this, you need to make sure that your mode is in radian and not degrees. Because I know a lot of you are in physics, you probably might have done some physics before you did this. I don't know. If you haven't, then if you have, then you need to change your mode over to radians. The other thing is that you have an extremely small interval, 0 to 1/6. So what we're going to do first before we deal with that aspect is we're going to go ahead and graph this out. So f of x equals cosine of x. So if you would please, go ahead and do that. Cosine pi x. And you're going to parentheses all, you close parentheses on that side over there. You don't really have to, but it's always a good idea to get in the habit of doing that. And this time, instead of hitting zoom standard, because you're dealing with trigonometry, you need to hit 7, zoom 7, Z trig, mystery Bob. So hit 7, and looks like I punched something in wrong here. So let's go back over here. Yep, I'll show you. All right, let's go ahead again. And let me make sure it's 7. Okay. Now you'll notice here that you have all these multiple sine curve waves, or cosine curve waves actually. They call them sinusoidal waves because they look like sines, but this is actually sine shoved over 90 degrees. Regardless, because there's no definitive, there's a constant changing point of height. The critical point, there is no critical point that's constantly changing. You have both a horizontal and a vertical going on there, so there's no critical point here. So, because there's so many of them. So what we're going to do instead here, first of all, recognize that that's what it's supposed to look like. But now, because we're dealing with such a small sliver here, which is just part of this first curve, 0 to 1/6, it's very, very small. So what we're going to do here is we're going to go back to the window, and we're going to put 0 for x minimum. We're going to put 1 divided by 6 for x maximum, and when we hit enter, you'll notice it gives you the decimal form of it, which is good. Now, in this case, I kind of want to see the little divisions for that. So I want to see 10 divisions from the beginning to end. So if you divide 1/6 by 10, you get 1/60th. So for your x scale, I want you to put 1 divided by 60. And you can leave everything else alone. And then hit graph. And this is what you get. And again, this shows the weakness of the TI calculator's ability to show little nuances in curves. You do see a little jump down above that 5th dot. And that tells you that this is actually a curve here ever so slightly going down, kind of like this thing right here. Okay? So, when I go ahead and do this, trying to find the two extrema, right here and right here. So I start with 0. So I'm going to this right here. Oh, likes the red, that's nice. So f of 0 equals cosine of pi times 0, which is the cosine of 0. Well, what is the cosine of 0? Well, if you know your sine and cosine, you know that cosine of 0, radians or degrees, either way, is 1. So that means that this point right here is 0, 1. That is our maximum. That is the highest point there of this interval. Okay? And that is your left edge. Then this is going to be 1/6 right here. So we go ahead and put f sub 1/6 equals cosine of theta times 1/6, which is theta over 6. And if you know your trig tables, that's 30 degrees. Cosine of 30 degrees is square root of 3 over 2. You calculate, I believe it's like 0.866. I'll use square root of 3 over 2 here. Very subtle drop in the curve of slightly more than 0.1. This is your right end, and in this particular interval, this is your minimum. There you have it. Your assignment, page 169, 20, 22, 26, 30, and 34. Have fun.